Good morning and welcome to the CCSP study session. Today we're going to go over identity access management, particularly federation methods and different methods of access control. If you have any questions during the session, please type them in the chat. I'll be sure to get to them. And if you want me to focus on any particular topic, please let me know. I'll be happy to cover whatever you're having trouble with. This study session's for you. So when it comes to identity access management, you have different control models. Access control is achieved when users are first identified and then they're authorized. So access control models are methods of authorizing users to your network. There's a few major access control models that we'll go over today. And access control can be managed through, in a Windows environment, Windows Group Policy Editor, or in a Linux environment, a database linked up to a protocol such as LDAP, a Lightweight Directory Access Protocol. So you need to have a directory list of users in order to conduct access control. Role-based access control is where users are placed into roles, usually based on their job function. So you'll have different jobs, different roles within your organization, and each one of those roles will have a different set of privileges. In this manner, you can easily delineate what resources and what folders users have access to or should have access to based on their job duty and their description. Those two can be linked. If you have a sales department, people in the sales department should have access to client lists, sales folders, the sales software, etc. A sales manager would have all of the permissions that a salesperson would have, but they would also have access to managerial tools. An HR representative or an HR manager might have access to employee records and payroll software, but they wouldn't need access to the software needed for sales. And a system admin would be able to set roles for each of the individuals and manipulate network security devices, permissions that the salespeople and the HR individuals would not need to have access to. Role-based access control can be hierarchy-based or job-based, or a combination of both. So in our previous example, we have a hierarchy in the sales department. We have a sales manager and then a salesperson. We also have job-based roles with sales, sales manager, HR manager, and system admin. So if we have a sales department with sales members, and then we have a new employee or a new type of job, like a temp worker, we would want to create permissions based on that role, that temp role, that would probably have less permissions than the sales group. Now, roles can be set for each user individually. In each user's individual account preferences, you can set up what they have access to, what software, what accounts, what folders, what network resources, or you can manage this through groups. And groups make the whole process much easier. Groups allow you to manage privileges all at once for a set of users. Excuse me. So in our example, we have a sales group. So say we have a sales group with several individuals: Jim, Dwight, Andy, Phyllis, Stanley, and Pam. Okay, all those individuals would have similar privileges. They would need access to the same type of resources. So they could be placed in a sales group. You'd manage this group with Windows Group Policy Editor. You would create a group and set the permission levels for that group. You'd set permissions to different files, folders, and network resources. Say one of the individuals, Andy, gets a promotion to manager. Instead of going into Andy's account and setting up all the permissions manually, you can just take Andy out of the sales group and put him into the management group. That's just a simple solution to move the user, and it has a few advantages. One, it ensures that the user gets the exact correct permissions because the permissions are handled via the groups. Okay, there's a less chance of user error in configuring those permissions because the groups only need to be configured once for several individuals. So as long as you're configuring your groups correctly, you will be able to ensure that everybody has permissions they need. It's also easier to detect when a misconfiguration occurs because everybody in the whole group will lose access to a resource or gain access to something they don't have. So it's easier to detect. You have more people who are exposed to that misconfiguration. This also helps enforce least privilege. Because the permissions are assigned from each group, when you take somebody out of a group, they lose the permissions that they had from that group. Okay? This means that they won't be carrying permissions from role to role, a term known as permission sprawl. So you won't have that because you're just taking them out of one group and putting them in the other group. They only have the permissions that they need to get their job done. That helps least privilege. It's also much easier and less time-consuming to configure for specific groups than for every individual. If you have a company of 100 employees, but you have 8 different job functions, you would only need 8 groups. You need to configure it 8 times instead of configuring 100 times. Rule-based access control is, as it sounds, based on rules. And these rules are managed through access control lists, or ACLs. ACLs allow you to set rules for your for what level of access each user has, and the rules are stored in an ACL just like a firewall. On a firewall, you would store permissions for each program, protocol, or service in an ACL, and once traffic goes through the firewall inspects the traffic and determines if it meets the rules. If it meets a criteria that says, okay, this traffic needs to be blocked, then the traffic will be blocked. Some rules can trigger actions as well. So like an intrusion prevention system could detect traffic using an ACL. Okay, say your ACL wants to detect any traffic on port 63. Traffic comes in through port 63, and the IPS says, okay, if any traffic is detected, block the traffic. So if you have the port open, you detect the traffic, you block the traffic. Or if any type of protocol that is not this protocol is detected over port 52. Okay, so if you have a protocol that is outside of the parameters that you've set for that port, then the IPS can detect, okay, this protocol shouldn't be communicating on this port, so I'm going to block that port off. So rule-based access control is more of a general term. It has a broad usage, but just know that it's based on rules. It's pretty easy to remember, honestly. Discretionary access control, or DAC, is a very common access control method. And it works by designating objects. Objects are files and folders, basically. Think of them as files and folders on an operating system. So each object will have a designated owner. That owner is responsible for assigning permissions for the objects they control. This system places access control in the hands of the users, which has its advantages and has its disadvantages. If you're relying on users for security, you're going to have poor security. Users are operating, most users don't have security foremost in their mind. They're trying to get whatever tasks they want to get done. Okay? So discretionary access control, relying on users on its own, is not a good system. It needs to have some method to enforce security policies rather than just the users themselves. The best example of discretionary access control is Windows. Windows uses the New Technology File System, or NTFS. And this file system uses DAC. Users, when they create a folder, they're the owner of their folder. Or they create a file, they're the owner of that file. The user can determine who else can access that file and what level of permission they can access. The level of permissions include read-only, write or modify, and then the owner, the full, which gives you full permissions in every category. To store who can access files and folders, Windows uses DACLs. Okay, they're like ACLs for discretionary access control. Discretionary access control, ACLs. So each object is assigned a security identifier, which is unique for each object, and then the DACLs store what users have access to each of these based on the security identifier. So this all happens in the background of the Windows operating system. Users rarely, if ever, get to see a security identifier. Unless you go looking for it, you're not going to know this exists. But that security identifier is used to identify uniquely each file and folder on the operating system so that ACLs can be kept. Mandatory access control is used primarily for U.S. government systems and some other countries as well to organize and control permissions for classified information. Mac uses sensitivity labels, and for the U.S. government it uses classification levels. The 3 levels of classification are confidential, secret, and top secret. Users require a clearance level commensurate to the classification level of the data that they're trying to access in order to access that data. So the 3 clearance levels, you can have confidential, secret, top secret clearance, and then there's certain programs that users can be read onto that they're called compartments that users will need to be assigned to different permissions within those 3 classification levels. This happens mostly at the top secret level, but there are some compartments at the secret level as well. And just because a user has access to secret or top secret information doesn't mean that they automatically gain access to all of the information at that classification level. Users should only be granted access if they have a need to know. So they need to have a clearance level and a need to know to be able to be exposed to the information. Realistically, most computers with classified information are segregated based on the level of classification they process. So you're not going to find a secret system that has top secret information or an unclassified system that has secret information. You shouldn't. If you do, you have a problem. But a top secret system can process secret information. You have a hierarchy, and the higher levels of clearance and classification can process the lower levels. So a top secret system would be able to process secret and confidential information. Mostly this comes into place, like I said, you're not really going to find a secret system that's processing top secret information those are usually kept on completely separate networks. What you're going to find is that at secret and top secret, those levels, you're going to have different compartments or different areas where users require special access on top of their clearance. And that's where mandatory access control comes mostly into effect. Users will need special access, special permissions to control those areas, to access those areas within that top secret environment. And they would need to be read onto those programs and then granted access to those different specialized classification levels. Mac is primarily used with Windows systems. The vast majority of operating systems that run mandatory access control are Windows systems, and that's what the U.S. government uses for these. There are a few exceptions, are a few Unix systems that operate with Mac, but just remember, mostly Windows. Okay. Attribute-based access control is based on access, or attributes. Okay, and these attributes can be pretty much anything you want. So you determine an attribute for each user, and then based on those user attributes, you assign access control privileges. This is very useful for fields in which professional licenses are required. So financial advisors, for example, need a professional license to operate in any given state in the United States. Okay. If they don't have a license to operate or to provide financial advice in that state, they're not legally allowed to provide that financial advice. So because of that, since you need a license for each state, you might want to assign an attribute saying that this person is certified, that this person has a license for X, Y, and Z state. Okay, so this person has a license for Arizona. That would grant that user the ability to access client information on the network for clientele from Arizona. So let's say we're talking like a nationwide financial advisement firm, okay, like Charles Schwab. So they might use attribute-based access control to customize their access control to meet that organization's needs. Attribute-based access control, or ABAC, uses policy statements, and these statements are usually very easy to understand. Okay, so you might have a statement like, all Red Hat employees are authorized to access databases at the Chicago office on Wednesdays. So that's just a statement that can be spoken and understood by anyone. Okay, but these statements need to have four main parts. You need to have a subject, which is the user. The object is the resource that the user wants to access. The action is what they want to accomplish, usually access or modify. And the environment is anything other than the subject or object. So in our example here, the subject's the red-headed employee. The object is the database. The action is that the user wants to access that database. And then the environment, the outliers, are the Chicago office. You're specifying a certain geographical region. And then on Wednesdays, you're specifying a certain time. So the environment doesn't have to be a physical environment. It could be anything other than a subject or object. So it could be a time. It could be, based on whatever parameters you want. As long as it's not describing the subject or object, its environment. All right, let's go on. First off, are there any questions about access control methods so far? Okay. Let's go into physical security now. let's talk a little bit about physical security methods for a data center, because I think it's useful to take a look at this every once in a while. So we'll be talking now about domain 3. We just went through access control, which I believe that's domain 4. Any other questions on domain 4 right now? We should talk about federation actually before we move on. Let's talk about federation here. Okay, to understand federation, you first need to understand what single sign-on is. Single sign-on is a method that allows a user to authenticate only once and then achieve access or be authorized for multiple resources. So they're authenticated once and they're authorized for multiple things, multiple resources, either multiple files, multiple networks, multiple folders, whatever you have. This is very useful if the user regularly requires access to multiple devices or software for their normal job duties. It makes the user's life easier because they only have to memorize one password. It can make password control a lot more streamlined. You can set up strong password policies for that one master password and ensure multi-factor authentication is used for that one master password, and then you have a good password policy that the user is more likely to keep track of and safeguard. If they have multiple passwords, say a user has to log in 8 times to 8 different resources, the user is more likely to start using poor password practices, like writing down their passwords or using the same password for each one or using simple passwords. And it also increases the workload on the security team. They need to set up password policies for each account. They need to accept and handle user requests to change passwords for 8 accounts. It's very time consuming, not only on the user side, but on the administrator side as well. So single sign is a very good solution. It streamlines the whole process. Because you're only using one password, though, you need to have strong authentication methods. Oftentimes, it makes sense to use multi-factor authentication. Multi-factor authentication is using something you have, know, or are. And there are a few more methods that are coming up that are a little more accepted now, as in something you do or somewhere you are. But for the CCSP exam, you're only going to need to know something you have, something you know, or something you are. Something you do would be something like a swipe pattern or a certain pattern on a keyboard. To me, that's something you know still, but it's becoming more accepted to say, okay, that's something you do. But in my mind, just because you do a pattern doesn't mean it's anything more than something that you know. And then there's somewhere you are where using something like geofencing or geotagging, a device determines your geographical location, then you're authenticated based on that location. If you're only authenticated if you're on campus grounds for an organization or you're in the office building. And this could be determined with a mobile device. Concept of transitive trust is similar to federation. It's a property of mathematics where the transitive property, if A equals B and B equals C, then A equals C. The same thing applies with transitive trust. If I trust A or I trust A, or I trust B, I trust B and you trust B, then I should trust you, essentially, okay? And this is mostly used with LDAP, or directories, okay? In LDAP, you have a parent-child relationship within the LDAP hierarchy. And that parent-child relationship will allow for transitive trust to occur. So if we have a parent, B, has two children, A and C. Since the parent has B and C under its hierarchy, if Jerry were to authenticate to A, one of the children, A is already trusted by B, the parent. So C is already trusted by B, the parent, so Jerry should also be authenticated to C. It's the same thing. If Jerry is authenticated to a trusted entity by the parent, then Jerry should also be authenticated to any other trusted entities by that parent. It's a form of single sign-on that is used particularly with LDAP. Now, federation occurs when a group of organizations decide to share authentication methods. So users from each member organization are authorized to access the resources of any member. So once a user is authenticated with one organization, they're authenticated for all the organizations, and they're authorized to use resources within all of those. It doesn't guarantee authorization. Authorization would be based on what that user needs to know, either rule-based or role-based or whatever access control method the organizations are using, but the authentication would be accepted by all of the organizations. So that doesn't automatically mean that the user is authorized to all of their resources, all the resources in every organization within the federation, but they could be. They are already authorized, and that authorization is shared and accepted. So this is like single sign-on for a group of organizations. To implement federation, you need a federated identity management system, okay, and that will handle the authentication requests on behalf of all those organizations. This is going to be a trusted third party. In cloud environment, usually this is handled by CASPs, or Cloud Access Security Brokers. Cloud Access Security Brokers handle encryption keys. They handle identity access management methods like federation. So a group of organizations might decide that they want to all join in a federation and then share their authentication load amongst themselves. Let's talk quickly about some of the methods for performing, or some of the protocols that are used to do this. So we're going to talk about some federation services real quick, and then we'll wrap it up. Okay, so we just talked about single sign-on federation. Security Assertion Markup Language, or SAML, is an XML-based system for single sign-on. This allows multiple websites to implement federation, because multiple websites can all share the same authentication method. So SAML is XML-based, okay? It's a markup language, just like HTML is a markup language, but these two are very different, XML and HTML. I'm not going to get into markup languages right now, but basically within XML, you set up data based on data tags, okay? So SAML can be used to authorize a user for one web resource, and then automatically that user is authorized for other web resources also within the same federation. SAML has three main roles. You have the principal, okay, the identity provider, and the service provider. The principal is the user usually, the person or the entity that's accessing the web resource, like the web application, the website. The identity provider is the person responsible for managing information on the user. So that identity provider is basically managing the user database. And then the service provider is the web host, okay, the entity that's hosting the web resource or the website. So when a user attempts to connect to the website, the service provider will read that user is trying to connect, and they'll contact the identity provider to try and identify the user and pass the user off to that identity provider so that the user can authenticate. And once the user authenticates, then they're authorized to access that web resource, and they can be authorized to access other web resources using that same authentication. OAuth is an open source standard, or is an open standard for authentication that allows federation between companies. Okay, this allows multiple companies to use the same authentication method to share company resource. And this is often used with web applications. Web applications might set up an OAuth connection to integrate other technologies with their web application through the use of application programming interfaces. So an easy example of this is if someone wanted to log into a website, they could either maybe create a set of login credentials with that website, or they can use like a Gmail, a Google, Facebook account information to access that, like Zoom. Zoom allows users to connect with their Facebook account or their Google account. That's an example that uses OAuth. OpenID Connect is another authentication protocol that works on top of OAuth. This allows the websites to verify the identities of users without having those websites perform the identity service. They don't have to store the user credentials. Okay, so OpenID Connect stores the user credentials on behalf of the web resources. It provides that user data store. This also allows for companies to tailor advertisements and to save user preferences, much like cookies, for a certain profile and then share that amongst a bunch of different companies. Shibboleth is another open source authentication protocol, and it's open source and it's managed by a nonprofit organization, has integrations for Java and C++ as well. So it's another authentication tool that can be used to perform federation or allow a group of websites to perform federation. Okay, so that wraps up our stream for today, our study session. Are there any questions before I close it out? All right, well, thanks everybody for attending. Stay studying, stay safe. I'll see you next time.